Hi everyone. We're going to look at a bunch of different scientific notation problems in this video. We're going to look at how to convert and then how to add, subtract, multiply, and divide with numbers that are written in scientific notation. The first one here says to convert our number into scientific notation. So first you need to know what that is. So scientific notation is a number, usually we call it d, times 10 to some power. So d has to be less than 10, and bigger than or equal to 1. Okay, it can be 1, but it cannot be 10. And then n is any integer. So it could be positive, could be negative, could also be 0, but we're not going to have decimals there for our scientific notation. Okay, so the way we do this is we take our number and we just move the decimal. So 4713 with 3 zeros. If you don't see the decimal, it starts on the right side. If it's ever not there, it's really on the right side. Now, we're going to move this decimal in until our number is in between 1 and 10. We want to find a number here that's in between 1 and 10. Right now, this number is way too big. If I move it 1 time in, our number is still too big. 2 times, still too big. 3 times. Now we've got 4,713. Again, still too big. Got to get between 1 and 10. One more time would be 471.3. Still too big. One more time would be 47.13. We're getting there, but that's still too big. That's bigger than 10. We got to go one more time. 4.7 is in between 1 and 10. So our decimal is going to be 4.713. Technically, those zeros are still there. We just don't really need them. Extra zeros on the end are just not necessary. So that would be the decimal. And now we're going to go back and see how many moves we needed in order to move that decimal. So we count our little loops here. So 1, 2, 3, 4, 5, 6. So this is 4.713 times 10 to the 6. But before you move on, always check. Is it a positive 6 or is it a negative 6? So the way you know if it's positive or negative is big numbers have a positive exponent. Okay, so this was a big number, so it's going to have a positive power of 10. So that is actually our answer, 4.713 times 10 to the 6. The next one is a small decimal, so that's going to have a negative power of 10. So we're going to take our decimal, this time we have the decimal given to us, and we're going to move it until our number is in between 1 and 10. This number is way too small, 0.000809 is way too small. So if I move it 1 time, 2 times, 3 times, it's still too small. If it's 0.809, that's still less than 1, that's too small. We want to get in between 1 and 10. So we're going to go one more time because 8.09 is in between 1 and 10. So we're going to call this 8.09. We're going to go back and count the number of moves. 1, 2, 3, 4. So times 10 to the 4th. But again, be careful. This was a small decimal. So our power of 10 is going to be negative. That's why it's 8.09 times 10 to the negative 4th. So small numbers have negative powers of 10s, big numbers have positive powers of 10s. Going the opposite way, if we've got 7.283 times 10 to the negative 3, that means our number has to be small. To make it small, we're going to move the decimal to the left. If you make it go to the right, it's going to make it bigger. I'm going to add in a bunch of extra zeros here. Way more than I need. Only need to move it 3 times. That's way more than we need. So we're going to move this decimal 3 times to the left, again to make it small since it's a negative exponent. 1, 2, 3 is our new location. So we don't really need all these extra zeros. So 0.007283. We no longer put the decimal here. It's been moved to this new location. And that's our number in standard form, how we normally see numbers. Again, small because it is a negative power of 10. For this one, we've got a positive power of 10, so it's going to make it very big. So this is going to be a big number. So 9.461. In order to make it bigger, we're going to move the decimal to the right. So we're going to add a bunch of zeros to the right. If you ever run out of space, just add more zeros if you didn't add enough the first time. So we're going to move this decimal 6 times. So 1, 2, 3, 4, 5, 6. There's a new location. Don't need those extra zeros. The new decimal is here, not in between the 9 and the 4 anymore. So it's 9461000. So that's our new number in scientific notation, or I'm sorry, in standard form. It was in scientific notation. This is our standard form, how we normally see numbers. If you'd like to, put the decimal on the end, but you don't really need it there if it's on the right side. You can just kind of leave it off. That's how we convert between the two different forms. Now we're going to do some adding and some subtracting. So what we've got here in the next one, we're going to do some adding. So first we're going to convert these into standard form, and then we're going to add them. So 7.28 times 10 to the fourth will make it big. So 1, 2, 3, 4. So that would be 72800. 9.02 times 10 to the fifth would be moving the decimal 5 times. Again, big because it's a positive power of 10. So 1, 2, 3, 4, 5. So that would be 902, 1, 2, 3. And I actually line these up kind of nicely right off the bat here. Make sure you always line up your decimals when you're adding or subtracting. If there is no decimal, it's on the right side, which is why I put them on the right side. And you've got to line these up so that they're lined up like this. You can't add them like this. It's not going to work. You've got to line them up where the decimals are lined up here. If you'd like to, you could rewrite it. I'm going to write the bigger one first with the decimal. And then writing the other one, and put the 800 first, and then the 2 and the 7, just to make sure I'm all lined up. Then we're going to add, bring down your decimal. And we get our new answer in standard form. This is not scientific though. Let's put it in scientific. To do that, move your decimal in between 1 and 10. So 1, 2, 3, 4, 5 times. So it's 9.748 times 10 to the positive fifth because it was a big number. That's how we add in scientific notation and convert back. Over here, we're going to again convert to standard form, subtract them, and then convert, or do your subtraction, and then convert back to scientific. So 1.15 times 10 to the negative 1. So we're making a small number because it is a negative exponent. So we're going to move the decimal 1 time to the left. 0.115 would be that one. 3.7 times 10 to the negative 2, again, would be small. Moving that 2 times to the left, 1, 2, in order to make a small decimal. So 0.037. Then we're going to just subtract those two things. I'm going to stack them up so my decimals are lined up. And then I'm just going to do my normal subtraction here. I'm going to borrow from the 1 and make this 5 into a 15. I can't do 0 minus 3, so I'm going to borrow. Looks like that's a 7, 8. 0 minus 0 is 0. And there we go. So that's our new answer after we subtract those here. But again, not standard form, or not scientific form. We got it in standard form. So that would be converting back. We're going to move our decimal in between 1 and 10. 7.8 is in between 1 and 10. So it is 7.8 times 10 to the second for 2 moves. But it's a small number, so it's a negative 2. Be careful with that exponent there. Got to be negative because, again, it is a small decimal. All right, moving on to a couple more here. We got some multiplying and dividing. So for multiplication, we're going to use the commutative property. We're going to rearrange some pieces here. Going to put the 3 and the 4.6 first and the 10s just second. You can always do that because of our commutative property. The commutative property says you can multiply or you can add in whatever order you'd like. Now we're going to multiply the 3 times the 4.6 first. So we can just stack those up. 3 times 4.6, well 3 times 6 is 18. 3 times 4 is 12, plus 1 is 13. And there's a decimal, there's one decimal, so one decimal in our answer, so 13.8. And then our powers of 10, we just add the exponents, keep the power of 10. Add the exponents, keep the base of 10. Now, this is not scientific because 13 is too big. It's bigger than 10. So we're going to write 13.8 as 1.38 times 10 to the first because you need one move in order to get it in between 1 and 10. Then you still have 10 more powers of 10 later on. So really this is 1.38 times 10 to the 11th as our final answer there. And lastly, one more problem here with division. For division, what we do is we split these up, 1.84 divided by 4, and 10 to the 5th over 10 to the 6th. And we divide each one separately. We're going to take 1.84. We're going to divide that by 4. If you do that, you get 0.46. And then 10 to the 5th divided by 10 to the 6th is actually a little bit tricky. That's 10 to the negative first because you got to subtract the exponents. 5 minus 6 is negative 1. This, again, is not scientific because 0.46 is too small. It's less than 1. So if we take 0.46, well, we move the decimal one time in, that would be 4.6 times 10 to the negative 1 because you have to do one more move in, and it's a small decimal, so it's negative. So this is really this. So we're going to kind of swap that out. So it's 4.6 times 10 to the negative 1 times another 10 to the negative 1 makes it 4.6 times 10 to the negative 2 as our final answer in scientific notation. So there's all 4 operations of numbers written in scientific notation. And again, up above, we had some converting problems as well. So that's kind of a quick little scientific review